So welcome everyone, and this is physics class, and this is circular dynamics lecture number 10. 10. What are we going to do in this lecture? I think in the previous class we had finished motion in a horizontal circle, and the last thing that we did was turning of vehicles on road. I hope all of you remember that. How does vehicle turn on road? Is not the steering wheel that turns it, it is the friction between the tire and the road that turns it. Road are also kept at an angle. We call it banking, the banking angle. And this because of this banking, the normal reaction, which instead of going vertical, goes at an angle. It gives us some centripetal force, which can help in turning on a circular track. And we had also seen that the formula for this maximum speed is root over mu s rg if it is only friction. If it is only banking, the velocity is the maximum velocity, maximum speed possible is root over rg tan theta. We'd also seen that if you are a motorcyclist or a cyclist, instead of banking the road, you can bank yourself and you can lean. And again, when you are leaning, you are changing the direction of your normal reaction, and that helps you in creating centripetal force, which is required to turn on a circular track. Well, now is the time that we get into another topic of this chapter, which normally I do before horizontal circle, but this time I have changed the sequence, and now I have done horizontal circle first, and I am going to do vertical circle after horizontal circle. So the next heading is motion in a vertical circle. Normally, everyone does this vertical circle first. I also used to do it, but this year I have changed it. And what I am doing is I am doing I've done horizontal circle first, and now we are going to do this vertical circle. Motion in a vertical circle. Now, what do you mean by a vertical circle? When we talk about a vertical circle, instead of, where is my book where I used to do? Yes, this is here. Instead of the body moving on this, like this, it will now move in this plane. This plane, it will move like this. So this is my new plane, the vertical plane. The plane could be like this. The plane could also be like this. This is also vertical. So it is your side wall. Body is going to move on the side wall, or the body is going to move on the back wall. Both are vertical walls. Up till now, the body was moving on ground, your floor, or your ceiling, or anywhere in between. That was horizontal circle. Motion in a vertical circle. Now again, we will be doing this in 2 or 3 different cases, and you must understand that those cases are not different. The only thing that is different is what is giving the body the centripetal force. In some cases, centripetal force would be given by normal reaction. In some cases, it might be given by friction. In some cases, it would be given by tension in the string. In some cases, it would be given by force in the rod. Doesn't matter. Different cases are there, because in all these cases, maybe the case looks different, and that is why I have just classified it into different types. So the first thing that we are going to do here, the first case is motion on the outer surface, and I hope everyone writes it. Motion on the outer surface. Outer surface of a body. And that is the first heading that we are going to do. Motion on the outer surface of a body. Now, when I talk about this motion on outer surface of the body, I hope I am audible and visible to all of you. Can I have some raised hand that I am visible and audible to all? Okay, great. Okay, now when I talk about this motion on outer surface of the body, how is the body going to be kept? The body is going to be kept on a horizontal floor. The body will be kept vertically like this. Now this body, if I have to draw it, I would draw it like this. So what I'll do is, this is my body, and this body is kept vertical. This body is kept vertical. Now, when I say that this body is kept vertical, what I mean is it is in the plane which is right in front of you, the screen on which you are watching, and you can see this circle right on your screen. So this is how the body is kept. Now this body looks round. Obviously it is round, but a round or a circle is a one-dimensional figure. You can't keep a body on a one-dimensional figure. So this round thing could be a cylinder. This round thing could be a cylinder. This round thing could be a sphere. This round thing could be a spherical shell. This round thing could be a ball. This round thing could be a ring. This round thing could be a disc. Doesn't matter unless and until it is round and you have kept it on the horizontal floor. It looks exactly how you can see it on the screen right now. This is exactly how it looks. So I keep it like this. Then what do I do? Since the body has to move on the outer surface, and as you can see, the pink one is the outer surface. The body is also going to move on the inner surface. We'll just do it now, or maybe we'll do it afterwards. Body is going to move on the inner surface as well. Right now it is going to move on the outer surface. So I keep the body, to start with, I keep the body at the top, right at the top. And at the top, let us say the mass of the body is m. And at the top, let us say that the body is at rest. The body is at rest. So I hope you understand the scenario. I have a cylinder or a sphere or a ball, anything that is round, kept on the surface. So this thing, round thing, is not going to move. In very complicated problem, this round thing is also going to move. So that makes the problem very complicated. This round thing is fixed. So how do I show that it is fixed? Oops, wrong color. I'll use a black color and I will just put it on ground and make it fixed. That this damn thing doesn't move. Great. Now it is kept at the top, at rest. Nothing will happen. Now imagine if I give it a small push, very gentle, smooth push I give it. And remember, when we are dealing with this sort of problem, we will not think that the body, there is any friction. So all the bodies, unless otherwise stated, they are going to be frictionless. So friction is not going to come. So I'll just note it down as well. All the surfaces are frictionless. So there is no friction. When friction comes, nothing happens. That's the problem, gets one more equation. The other equation changes and nothing else. Right now, let us not concentrate on friction. Frictionless, that is smooth. The surfaces are smooth. That is the type of question that we encounter in 99.9999% of cases. So our body is kept at rest and I give it a gentle push. What happens now? What happens next? Tell me, anyone. What happens next if I give this body a gentle push? What happens if I give this body a gentle push? What will happen to this body? A very, very slight push. No one has the answer? Online class, offline class, no one has an answer? What will happen if I give this body a gentle push? What happens to this body? Does it move? Does it not move? How does it move? If it moves, how does it move? There is no friction anywhere. It is frictionless, smooth surface. What happens to this body? Anyone? No one has any idea? I'm waiting. Round body, round
Move.
surface. A body is kept on the top. I give it a gentle push. What happens, beta? Bolo.
Move, sir.
Can you be a bit loud? I can't hear you, bacha.
Body will move, sir.
Body will move. How will the body move? Does the body move on a circular path or not? Is it difficult to analyze? Is it difficult to understand that the body, no one is able to make out that the body is
Moves
going
back,
how?
sir.
Yes, beta.
It moves back.
It moves.
Back, sir.
It moves back. Back. I mean, I push it like this. It will move back. Huh? No, I don't understand it. How does it move back? If I push it forward, how does it move back? There's nothing pushing it back. Okay. Anyone else? No, I don't
Body
know
will
what.
move back. Front, sir, and friction acts backward.
Okay, the body will just move on a circular track. It will just go down like this. Let us say this point is A. The body just moves down the circular track. That simple. I don't know what's so complicated here. At some point in time, the body reaches this point B. This is the point B. And the body reaches here. As you can see, the body has moved from point A to point B. And definitely, it has followed a circular path. Yes or no? Do we understand this? Body will move from A to B, maybe downwards, more on the downward side. It will move on a circular track. Am I clear with this? Or
Yes,
do we
sir.
have any other understanding of how the body is going to move?
Understood, sir.
Okay, so the body is going to move. Let us say it moves from A to B. Now the next question, that is a common sense question. Will the body keep on moving on this track, or does anything happen? Will the body keep moving like this? Like this? The body just kept on the surface. Will it keep on moving like this, or something happens before this body comes down? Will something happen? Or will the body follow this track that I have created for it? Will the body keep on moving like this? Or will something happen before this happens?
It falls down, sir.
Yeah, at some point it falls down. Now instead of calling it as falling down, it is still falling down. Instead of calling this as falling down, we will call this as it will lose contact with the body. At some point, it is going to lose contact with the round body. Do we understand this? Yes or no? Can I have some raise hand that you understand this? If I give it a gentle push, it will move. It will move probably for some time, and then it will just lose contact and just fall on ground. Okay, so we understand this. We'll do at what point in time it not point in time, where does it lose contact? We will be doing this question also. Right now the body is in contact, and let us say that this body has turned through an angle theta. This body has turned through an angle theta. I hope everyone can see this. The body has moved through an angle theta. Now, when it has moved through an angle theta, let us first see what all questions can be asked here. The scenario will be given to you and they will be asking you questions. What all questions can be asked? The first question they can ask here is, at this point, the body will have some velocity. That is the most important question here. What is the velocity of this body? That is the first question. The second question is, the body is in contact, so there would be some normal reaction. What is the value of this normal reaction? Second question. The third question that can be asked is, what is the value of the tangential acceleration? The body is accelerating. The speed of the body is changing. At the top, the speed is 0. It is at rest. Now the speed has become v. The direction is also changing. So there is centripetal acceleration. The magnitude is also changing. So there is tangential acceleration. How much is the tangential acceleration? And the last question that could be asked, this is not the last, there could be more questions, but the general ones. What is the centripetal acceleration of the body when the body has turned to an angle theta? Once you know the value of AT and AC, you can calculate the value of acceleration. I will give you a minute to think about it. Think about it and tell me how you are going to do it. A minute, 2 minutes. I hope everyone has drawn the diagram. And now I would like to ask, how are you going to solve these basic questions? Any idea, anyone? Ideas are important because that makes us understand how much we can analyze a question. And remember, whenever a question comes, now I'm not talking about JEE Mains. JEE Mains, the questions are very nominal, very simple. They don't require much of understanding. They are basically meant to test your speed. But in JEE Advanced, whenever you encounter a question, some questions would require thinking. And you will find that the question is a new one and you have not seen it. So if there is a question that looks like a new one that you have not seen, you must know how to attack it. What should you do? This question also looks like new because we are doing it for the first time. So I would like to know your thoughts. What you think should I do to solve this question? I have to find the value of velocity v, I have to find the value of normal reaction, I have to find the value of tangential acceleration, I have to find the value of centripetal acceleration. Your thoughts, please let me know. What do you think? How am I going to solve it? Anyone, any idea? No idea is right, no idea is wrong. It depends on which idea is applicable where. So no idea is right, no idea is wrong. Anyone can tell me how are we going to solve this question? No one knows it? No idea, anyone? Come on, speak up. No one has any idea in the class? How are you going to do this?
Velocity depends on force applied and gravitation force.
Velocity depends on force applied and gravitational force. Does the what about normal reaction? It does not depend on gravitational force. Tangential
Yes,
acceleration? Yes.
Yes, sir.
I'm asking you, how are you going to solve the question? What you should do to solve the question? And I don't think that your answer, whatever you have told me, gives me any idea of how to solve the question. I'm saying how to solve the question. How are you going to solve this question? Anyways, I've already told you the method, but you don't seem to recollect. That's a failure on my part. that whatever I tell you, you don't seem to listen to it and you don't seem to follow it.
Draw FBD.
Yes, bacha.
Draw FBD. Free
Yes,
body diagram. Free
free
body
body
diagram.
diagram. I've already told you the steps that we need to do. You just have to follow those steps. But here I also would like to add just a reminder, whenever you ask about a force, normal reaction is a force. Whenever you are asked to find out the value of any acceleration, whether it is tangential or whether it is centripetal. Now, in these three cases, whenever you are asked about any force, whenever you are asked about any acceleration, all these questions that are about force and accelerations, they have to be solved using the equation of force dynamics. You have to write the equation for force. And how does the equation for force comes? The equation of force comes from free body diagram. To solve all these three, whether to find out the normal reaction, wrong color, whether to find out the normal reaction or to find out the tangential acceleration or to find out the centripetal acceleration, wherever you are asked to find out any force, wherever you are asked to find out any force or you are asked to find out any acceleration, you must always look to draw free body diagrams and get your answer from there. But whenever you are asked to find out velocity, obviously from acceleration you can find out velocity. Yes. You know the force, you can find out acceleration, from there you can find out velocity. Yes. But more often or not, in 99.9% of cases, whenever you are asked to find out just velocity, no acceleration, no force, no time, someone just asks you to find out velocity, and I've repeated it many times, but it's a failure on my part that I can't make you concentrate on one point, and you don't seem to find time at your hostels to go through the lectures once again. It's a failure on my part, and I'm very sorry for that. Because if you don't do that, results are going to be on the similar lines, and I will feel very sad if that happens. Failure on my part. What do? I'll try to improve. I can guarantee you that. Whenever you are asked to find out the velocity of any particle or speed of any particle, the first thing that should come to your mind is this question has to be solved using what? Whenever you are asked to find velocity, whether it is velocity or it is angular velocity in rotational motion, the first thought that should come to your mind that this question has to be solved using what? Using the work energy theorem, WET, or law of conservation of mechanical energy. In almost 99% of the cases, whenever velocity or angular velocity is asked, you have to apply this. You have to apply work energy theorem, find out the work done by all forces. To find out the work done by all forces, you must know forces. So you must draw free body diagram. So in any case, you have to draw free body diagram. No matter you are doing the question by force dynamics or you are doing the question by work energy theorem, you have to draw a free body diagram. I repeated it many times. Again, I repeat it once again to cover for my failure that I can't make you understand it in the first case, and I was not able to get your attention on this fact that whenever velocity has to be found out, use work energy theorem or law of conservation of mechanical energy. I hope this makes it clear. Anyways, this was all about in general when we are talking about this. But again, if I go 4 classes back, I had already given you the steps of solving any problems in force dynamics. Already given you the steps. Again, failure on my part that you don't remember it. And we have done so many questions. A big failure on my part that even after doing so many questions, you don't know how to do the next one. It's a big failure on my part, and I'm very sorry for that. Anyways, no matter what the question is, again I repeat myself. I've been failing a lot. That you can't remember one simple thing. That every question has to be done in one similar way, which you have been doing it for the past 5 days at least. But still you don't seem to recollect. Failure on my part. The first step is obviously to draw a free body diagram. That is what I'm going to do. I'm going to draw a free body diagram. The weight mg is always vertically downwards, and I have drawn this figure in the vertical direction. Weight mg comes down. Is there any other force acting on this body? Acting on this body? Please let me know. Or is mg the only force acting on this body? Is there any other force? Yes or no? Is there any other force, bacha?
Sir, normal reaction.
Okay, and how should I draw the normal reaction? In which direction should I draw it? Upward, downward, right?
Perpendicular to the surface.
Okay, so perpendicular to the surface, and it goes like this. So now we have an understanding. Let me take this out, velocity. So I have to find out the velocity. I know that. I have drawn the normal reaction. So far, so good. Now again, remember, I have drawn the free body diagram. I have to resolve forces. Forces in 3 directions. One direction, the first direction is tangential. Now, what is the tangential direction here? Everyone knows it. Can anyone tell me what is the tangential direction here? First of all, you have to understand that if this angle is theta, and I hope everyone is doing it with me, this angle is also theta, alternate angles. Now, I have to resolve the forces into 3 directions: tangential, centripetal, and perpendicular. Normal reaction is going in which direction? Normal reaction is going in which direction? Anyone? It is going in the centripetal direction. But weight mg is coming down, so I need to resolve weight into 2 components. Can anyone tell me what are the 2 components in which I will resolve the weight? I'm waiting for your answers. The 2 components in which I have to resolve weight. One component will be like this, along the tangent, tangential. The other component, and I'm short of color, so what I'll do is I'll produce another color. And what is the color should I produce that looks different? I think this one will look different. Okay. And the other direction is like this. So one is the green direction, and I'm colorblind. I don't understand color, so I call this color as maroon or whatever it is, dark brown or maroon or whatever it is. So one is the green direction, and the other one is the maroon direction. Maroon direction is towards the center, and the green direction is towards tangential. Can anyone tell me how much is the green one equal to? How much is, oh, why I'm using maroon color? How much is the green one equal to? How much is this equal to? Anyone? Well, it is equal to mg sine theta. I will
sine
not.
theta, sir.
Yes, bacha. Well done. Mg sine theta. You have taken a lot of time, and till that time I have to move forward. Mg sine theta is the correct one. Then if this is mg sine theta, then all of us know.
Another one is mg cos theta.
Another one is mg cos theta. Yes, bacha. That is absolutely correct. I have resolved the forces in the 2 directions. Now I should follow my step. My first equation is equation in the tangential direction.
Equals to
Ft. How much is Ft here? How much is Ft? Tangential force. Everyone can see this. It is right there on your screens. In the diagram. That is why diagrams are so important in physics. Without diagram, you can do. Yes. It is mg sine theta. And that must be equal to Ft, and Ft is always equal to m into At. Do we understand this? Can I have some raise hand that we understand this? Yes, well done, bacha. Then I cancel m, and I welcome the first answer. The tangential acceleration is g sine theta. The tangential acceleration is g sine theta. Do we understand this? Now remember, I must ask you this. That is very prudent. Is this acceleration that I've got, is it variable or is it constant? Is it a constant acceleration or is it variable acceleration? If it is variable, is it varying in direction? Is it varying in magnitude? Or is it varying in both direction as well as magnitude? Is it constant?
Varying in the direction, sir.
It is varying in direction. What about magnitude? This is a variable acceleration. It is definitely varying in direction because at all points it is changing direction. It is varying in direction. What about the magnitude? Is it constant in magnitude? Is it constant in
Yes,
magnitude?
sir.
Look at the value. What
No,
is
sir.
what does the
Magnitude is not constant.
yes? There is a sine theta here. Theta
Yes,
is changing. At the top, theta is 0. Then theta will slowly increase. 0, 5, 10, 15, 30, 40, 45. Theta will keep on changing. So the value will also keep on changing. So it is variable both in magnitude as well as in direction. It is continuously varying both in magnitude as well as in direction. Do we understand this? Can I have some raise hand that we understand this? It is a very, very difficult acceleration. It is varying in magnitude. It is also varying in direction. That makes it tougher. I hope we have written the first equation. I'll give you a minute to note this down because I'll have to scroll down. Let me, I can do without scrolling down. Okay. So let us first, since we've written tangential equation, let us write the second equation, which is the Maroon equation now. The Maroon equation. And in which direction do we write the second equation? In which direction do we write the second equation?
Centripetal direction.
In the centripetal direction, I write Fc. This Fc is always equal to m, mass of the block, v square. That is the velocity that we are looking for, divided by r, where r is the radius of the circle. I did not tell you the radius of the circle. Let us take the radius of the circle as r, which is normally given to you. mv square by r, this is the centripetal acceleration. And can anyone tell me now, how much is this equal to? The free body diagram is right in front of your eyes. The answer is on your board. Can anyone tell me what is the answer?
V square by r.
Yes? mv square by r is the value finally. But there has to be some force which is giving you this value. What is that force that is giving you this value? Centripetal force. Think about centripetal force, my dear friends. Fc, mv square by r. Look at what is in the centripetal direction.
Sir, mg cos theta.
Look at what is in the centripetal direction. Open your eyes and see again. You might find something else there. Open your eyes, see again. Do you see anything else? Or you only see mg cos theta? No one sees anything else?
mg cos theta minus mg cos theta
mg cos theta?
is equals to n.
mv square by r is mg cos theta, which is towards the center, minus n, which is outwards. Do we understand this? Yes or no? Please let me know. mg cos theta is towards the center, normal reaction is outward, so this becomes positive, that becomes negative. mv square by r is mg cos theta minus n. Do we understand this? Can I have some raise hand that we understand this? Anyone understands this? Anyone has a doubt? Please ask.
Clear, sir?
Clear, sir. Then, sir, it takes us to the equation number 3, sir. Now, will I write this equation? I will draw it in. I will write it in black. My favorite color, black. Third equation is the equation in the perpendicular direction. Now try to understand what is the perpendicular direction here.
F perpendicular is equal to 0.
This is the perpendicular direction. Do we see any force in this direction? No, 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 no.
Zero.
Even if there was any force, the force had to equate. But here there is no force. So this equation is useless. It is not going to give me anything. So we don't worry about this equation at all. This equation does not give me anything. I'll give you a minute to think about it. Three equations. We have done absolutely similar things right from the first day. We are just making equations. In the force dynamics chapter, in this chapter of work by energy, force dynamics, we have been doing the same thing over and over and over again. We did on the three equation. I'll give you a minute to finish. Note down the three equations, then we will move further ahead in our quest for knowledge, in our quest to secure a seat in the prestigious colleges, engineering colleges of India. Minute to minute. So I hope everyone has copied
Yes, sir. Copy.
what we are supposed to copy. Now let us go back and keep on discussing the same question. We were supposed to find out four things: velocity, normal reaction, tangential acceleration, and centripetal acceleration. Up till now, we have only managed to find out one, which is your tangential acceleration, the green one. We have only managed to find out this part, the green one, tangential acceleration. Now, what I can do here is I can write this as equal to, this is centripetal force, so this is nothing but m into AC, because I know that this AC is nothing but V square by R. Do we understand this? Do we have an understanding on this? So if I get the value of velocity, I can find out centripetal acceleration. But the problem here in this equation, which is in blue, the blue equation has a problem. See, the black equation does not give me anything, so forget about the black one, it is useless. The blue equation has a problem. What is the problem that you see in the blue equation? Whether I write the blue equation like this, MAC is MV square by R, or I write it like this, MAC is
One
MG
equation,
cos.
two unknowns.
Yes, one equation and two unknowns. So it cannot be solved. No one in this universe can solve this equation. One equation and two unknowns. Now I need the fourth equation, which I never used up till now in horizontal circle. Now my question is, it is a very simple question and the answer is right there in front of your eyes. What is the fourth equation that I have to use? What is the fourth equation that I have to use?
Sir, we think pseudo force.
Sorry, I can't hear you, bacha.
We think pseudo force, sir.
I still can't hear you. Can you
Pseudo
be
force, sir. Pseudo force. Pseudo force, sir.
Pseudo force? Interesting concept, but it is not applicable here. Anyone else with a different idea? Why would I use pseudo force? What is pseudo force? Do you remember it? Why would I use it? The answer, I've written the answer right in front of your eyes. You still can't see it. You still don't remember the step that we have written.
Sir,
Big
work
failure on
energy
my
theorem.
part. I'm really very disappointed with myself.
Work energy theorem.
Yes, the answer is right there in front of your eyes. You only need to open it and see. You have to use the fourth equation, which is to apply the work energy theorem or law of conservation of mechanical energy. That is the fourth step that you have to reach. Applying work energy theorem. I'll just not go into work energy theorem. There is no friction, so I'll apply law of conservation of mechanical energy from point A to point B, from point A to point B, and that will give me one more equation, and that equation will actually solve this entire problem. Law of conservation of mechanical energy from point A to point B. That is my fourth equation. Now, how will I apply? I will tell you how it is applied so that you have an idea of doing it. So what I need to do first, since the diagram has gone upwards, I will have to draw the diagram again. And now the diagram that I'm drawing is only, what has gone wrong here? Shapes, this, let the shape come. Okay. Now the diagram that I'm drawing is only to apply Lockme and nothing else. So I will not draw anything which is not relevant. So this was the diagram. This is point A. And here we have point B, and I have to apply Lockme from A to B. I hope everyone understands this. This angle is theta, and this radius is R. R is the radius of this block. Now what I got to do is I need to apply Lockme. Lockme means mechanical energy at point A is equal to mechanical energy at point B. Mechanical energy at point A consists of potential energy at point A plus kinetic energy at point A should be equal to potential energy at point B plus kinetic energy at point B. Do we understand this? Yes or no? Can I have some raised hands?
Yes, sir.
Now to find out potential energy at point A, I have to find out some point whose potential energy is 0. So I take this point, the center of the circle, as potential energy 0 wala point. Now if the potential energy of this point is 0, what is the potential energy of point A? It will be equal to MGR. Yes, MGR is a very famous actor in South. MGR. MGR, sir. MGR. I hope MGR is his name, right? I'm hopefully not mistaken. MGR is the potential energy at point A. What about the kinetic energy at point A?
0, sir.
It is 0 because it is at rest. So far, so good. Now let us move on to potential energy at point B. To find out the potential energy at point B, what you got to do is you got to find this height. You got to find this height. Can anyone tell me how much is this height? I will not waste much time. This height will be equal to r cos theta. This is r, this is theta, so that one will become r cos theta. Do we understand this? Yes or no?
Yes, sir.
So this becomes mgr, again mgr into cos of theta plus kinetic energy at point B, half mv square. From here, you can easily find out the value of velocity. I will straight away write the answer. The value of velocity v would be equal to 2 times gr into 1 minus cos theta. Do we understand this? Can I have some raise hand that makes me understand that we have understood this one? How I have got the velocity of this block, and you, if you can remember this formula, you don't have to do the entire fourth step. You can straight away write the velocity as root of 2gr 1 minus cos theta. Do we understand this? Can I have some raise hand that we understand this, sir? Great. The velocity of this block is root over 2gr into 1 minus cos theta. Now, as soon as you get the velocity of this block, the entire problem gets solved. Once you know the velocity v, you can find out the acceleration ac by finding out v square by r. So acceleration ac, wrong color. Acceleration ac would be simply equal to v square by r. V is known. You can find out v square by r. Once you know the value of ac, you can use equation number 2, the blue equation, and you can find the value of n as well. That I will leave as an exercise for you. I hope you can do this with your own hands, sweet little hands, and you should be able to do this. Am I clear? Can I have some reason that we understand this, sir? No doubts. It's all clear. We have followed the step. I don't see much raised hand. That means there is some problem somewhere in my understanding or in my delivery of whatever I wanted to speak. Can I have some more raised hand that we understand this? This is the most important aspect of this chapter. Okay. I'll give you a minute to note this down, then I'll give you a problem, and that would be the end of the class today.
Sir.
Well done, everyone. If you have copied it, you have become smarter by the day, and that is what I was expecting. Good one. Now I'll give you a problem for you as homework, and I hope that all of you will post your answers in the. Okay, you don't have the Telegram group. You probably don't have access to internet. Anyways, this is a question for all of you guys to make you understand how this question can come. So this is how the question looks like. A block of mass m is on top of a cylinder of radius r, and it is at rest. It is given a small push. When the block makes an angle theta with the vertical, remember sometimes the angle is given with the horizontal. You have to be careful. When it makes an angle theta with the vertical, find number one, the velocity, number two, the normal reaction, number three, tangential acceleration, number four, centripetal acceleration. Instead of theta, you can take it as, just not take it as theta, otherwise the answer would be similar. Just take it as 37 degrees. When it makes an angle of 37 degrees vertical, find find velocity, find normal reaction, find tangential acceleration, find centripetal acceleration, and find the total acceleration. I hope you remember how to find the total acceleration when centripetal and tangential acceleration are given to you. Do you understand the question, everyone? I hope you will solve this question and you will be coming up with your answers and letting me know if you have access to the Telegram group. You would be posting your answers in the Telegram group. That's it from my side today. We have covered one part of this vertical circular motion. It will take some time for us to complete this. Remember, we are doing circular motion on the outer surface of a vehicle, outer surface of a round body, and we will continue with our discussion in the next class. Till then, take care and have a nice day. Bye bye.